Okay, so we're talking about the quadratic formula for section 4.7. The first idea here, how to solve any quadratic of the form ax squared plus bx plus c. We can always use this thing called the quadratic formula. I know you've seen it before. It's called, or it is, negative b plus or minus the square root of b squared minus 4ac over 2a. Rachel in our class has a really good story as to how you can remember that. So if you want to know how to memorize that, I suggest that you contact her. She has a really good story. Okay, so we're going to use this. Before we can use this, though, let's talk about when you should actually use the quadratic formula. So whenever you're given any quadratic of the form, the first thing you should do is try and factor it. If you can't factor it, you can always then try to move on to completing the square if your leading coefficient is a 1. That's what I mean by leading coefficient. If a is a 1, then completing the square is usually a good way to go. But if you don't want to do that, or the directions say to use the quadratic formula, then you can use that. You can always solve any quadratic using the quadratic formula. But it shouldn't be the first thing you try. You should try factoring and then completing the square, and if that doesn't work out, then try the quadratic formula. Of course, we could graph it as well, but it's more convenient just to go ahead and straight to use the formula. Okay, so let me give you an example, and I call this example of solving using the quadratic formula, and I call it Diorio's way. So the first thing you want to do is write it into standard form. So I'm going to give you 2x squared minus x minus 4 is going to equal now 0. I break this up into 3 parts. Part number 1, part number 2, and then part number 3. And I know you've seen me do this in class before, but I want to show you why I do this. The first thing is I just define what a, b, and c are. A is a value of 2, b is a value of -1, and c is a value of -4. That's all you have to do for the first thing, for the first step, okay? In step number 2, I just want you to evaluate this part, b squared minus 4ac, this part of the quadratic formula. I'm talking about this part right underneath here. Just do this part first, all right? It has a special name. We're going to talk about it in the next box, but just do that part first, all right? So here's what I'm going to get. I would get -1 squared minus 4 times 2 times -4. This is going to give me 1 plus 4 times 2 is 8, times 2 is 32, so I'm going to get a value of 33 out of this for my second step. Then, in my third step, actually apply the quadratic formula. So it would be negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's plug in what I know. Negative b would be 1, plus or minus the square root of all of this stuff. Now remember, all of this stuff is everything that you've done in step number 2. So the number 33 just goes here, because our answer was 33, remember. Divided by 2 times a, which in this case is 4. And you know what? We can't do anything more than that, so we would leave our answer just like that. The reason I have everybody do this step in number 2 is because that way you don't have to worry about it over here and get messed up with the algebra. So I'd highly recommend that you do it that way as well. Okay, let's do another example the same way. So the first thing I'm going to do is I label a is equal to 1, b is equal to 4, and c is equal to -3. That's all you got to do. Step 2, I would say, okay, what is b squared minus 4ac? Let's evaluate this. This is going to be 4 squared minus 4 times 1 times -3. This is going to give me 16 plus 12. That is going to give me 28. Okay? Step number 3, I'd say x equals -b plus or minus the square root of b squared minus 4ac over 2a. So therefore, I would have -4 plus or minus the square root of all of my hard work in step number 2, divided by 2 times 1 is 2. Now for this one, we can actually keep going, and I can break up that square root of 28. Okay, the square root of 28 is equal to the square root of 4 times 7, which can be broken up into square root of 4 times the square root of 7, which can be broken up even further into 2 square roots of 7. So here, I would have x equals -4 plus or minus 2 square roots of 7, all divided by 2. Now you can actually factor out a -2 from the top, and that will leave you with 2 plus or minus square root of 7, all divided by 2. And then you can see that the 2's cancel out here, leaving you with a -1 So when we're all said and done, we would end up with an answer of, let's see here, negative 1 times 2 would be negative 2 plus or minus the square root of 7, and we would leave our answer just like that. It is to note that you do have two answers here, right? So from this, x could either be negative 2 plus the square root of 7, or it could be negative 2 minus the square root of 7. But either one of those will make that equation true. Okay, in the fifth box, we're going to talk about the discriminant of a quadratic. The discriminant is located here. It's all the stuff in the highlighted portion underneath the square root. It is indeed the b squared minus the 4ac. And this plays a very, very special role. And what this does is this tells you how many and what kind of solutions you're going to have. Okay, that's very, very important. It tells you how many and it tells you of what kind. So the b squared minus 4ac is called the discriminant, and it tells you how many and what kind of solutions you're going to have. This can be three things. The discriminant could be a positive number, the discriminant could be a negative number, or the discriminant could be the number 0. It can be one of three things: positive, negative, or 0. Let's take the first case. If your discriminant is a positive number, that means that you will have two real solutions. Now these are numbers that are real numbers, right? Like 2.78, negative 1.34, any of those. Two real solutions, all right? If you have a negative, if your discriminant is negative, it will tell you that the quadratic will have no real solutions, but it will have two complex solutions. So for right now, the book will probably in the back will say no real. When we get a little further down the road in this class, we're going to understand it's going to be two complex solutions, or imaginary, okay? And the third thing that this could be is it could be the number 0. If it's the number 0, you're going to have one real solution. So only the number 2 or x equals 5 or something like that. So how many? That's this part here. It'll be 2, none, or 1, and of what kind. If it's negative, you're going to have complex. If it's positive 0, you're going to have real. That's what I mean by that. So let's explore this idea over here in fluid math. Okay, this is the last and final box. I have three examples for you of quadratics. I have the first one, negative x squared plus 2x minus 9. I have x squared plus 17x plus 4, and I have x squared minus 6x plus 9, okay? What we're going to do is we're going to look at the discriminant for each one. So we're going to look at this part, the b squared minus 4ac of each one, and then we're going to connect it to the graph. So in this case, I would have 2 squared minus 4 times negative 1 times negative 9. When you get all that, when you evaluate what that would be, that would give you a value of negative 32. Now I said over here in the notes, if your value was negative, you're going to have two complex or no real solutions. So what does that look like in terms of the graph? So if I graph this for you, here's what the connection that we should make. If there is no real solution, then that means that my parabola or my quadratic can never touch my x-axis. And you can see that in this case, it never actually does, right? Because if it did, then it would have to have a 0 somewhere or a root or a solution, but it doesn't. It's way down below here. So because my discriminant was negative, I know right away that my parabola will never touch the x-axis. That's for that graph for that one right there. Okay, let's take a look at this next one here. If I had 17 squared minus 4 times 1 times 4, this would be a number of 273. And if you actually compute that, you should get 273. Well, that number is positive. So according to my discriminant, I'm going to have two real solutions. So what does that mean in terms of the graph? So when I put this on the graph right here, you can see when I move out, here we go. You can see that this graph actually touches in two places, right there and right there. That's what that means by two real solutions. There are two spots where it crosses the x-axis. Okay, I'll get rid of this one now too. All right, and finally on this last one here, if we evaluate negative 6 squared minus 4 times 1 times 9, you actually get 0 for that. And according to 0, I would have exactly one real solution. So what does that look like for us on the graph? When I graph this one, x right there. Let's see if I can get it. No, let me move down a little bit. Here we go. Whoops, I think that's plus, right? Yeah, okay. There we go. Check this out. I get one real solution. What does that mean? That means that my graph only touches the x-axis in one spot. Okay? So by looking at the discriminant, we know a whole lot about what the graph says. All right? Good luck, you guys.